here's the key for your test review. Okay, so we got these guys on a seesaw. Steve and his friend are playing together on a seesaw, shown in the figure above. At t equals 0 seconds, the distance between the top of Steve's head and the ground is 24 inches. Okay, so that means this right here, 24 inches, because that's the start. At its highest point, Steve's head is 60 inches above the ground. So even though this isn't Steve, we can still say that this would be 60, just to help us out here. Steve goes all the way up and back down to the seesaw every 3 seconds. Okay? So if one cycle up and down is 3 seconds, my period is 3. As the two friends play on the seesaw, the distance between the top of Steve's head and the ground periodically increases and decreases. So we have the periodic function d models the distance in inches between the top of Steve's head and the ground as a function of time t in seconds. Okay, so here's the graph of d between the top of Steve's head and the ground. All right. So we know that when we start, he starts at the lowest point. So this looks like a good place to start. However, if I start here with 0, 24, then these would have negative times, and that's not good. So it is 24 right there, but it cannot be 0. What I know is that if I continued this, which you don't have to, but sometimes it helps to put that in here, I could make this 0, then all my times would be positive. So I can make this 0, 24. Then he's going to go up and come back down. We know that takes 3 seconds, which also means that this point, which they didn't ask me for, but I might need, is 6, 24. Might as well just go ahead and label what's on here. I know at the highest point, my y value would be 60, so both of these have a y value of 60. Okay? To get these y values here, I can average them halfway between 60 and 24. So I add them together, I get 84, divide by 2, that's 42, and this is 42. Okay, so I got all my y values in there. Then my x values, those are separated evenly as well, so I can add these two together, divide by 2. This is 3/2. And then to get this, I can add these two together and divide by 2. So if I add 3/2 plus 3, I'm going to make that 3 into 6/2. So that gives me 9/2, but I have to divide it in half to average. That's the same as multiplying by 1/2. So that makes this 9/4. And remember, we can think in terms of fourths if we want to. This would be 6/4. This would be 9/4. This would be 12/4, which is 3. You can do it, you can go about it that way. Or I can average 3 and 6 here. That gives me 9/2. And then I can add these together. 9/2 plus 3, which will make that 6/2. Will give me 15/2. But remember, I have to divide that in half, which is the same as multiplying by 2. So that's 15/4. Okay? And if you think in terms of fourths and you kept everything in fourths or whatever, that's fine. You wouldn't have to reduce. Okay, so now we are going to refer to the graph. The t-coordinate is f is t1, g is t2, so I'm looking at this part of the graph. It says on the interval from t1 to t2, which of the following is true about d? Which means what is true about the graph? I don't care about the rate. The fun chart really doesn't help me here. Looking at the y values. Y values are positive, and they're getting smaller. So we are positive and decreasing. We are concerned about the rate of change here, though. So here we do need our fun chart. And I want to know how the rate of change is changing over this interval. So on this interval, the function, we just said it is positive and decreasing, okay, but it's also concave down. It's concave down and decreasing, which tells me my rate is decreasing and negative. And there are things I have to make sure that I say in my, want to explain it correctly. So I would say, or actually let me do it this way. The rate of change of D on the interval T1 to T2 is, so I decided it is decreasing and negative because the function D is concave down and decreasing on that interval. And so make sure you have all of that. All right, so this one I told you to omit. It was a hot mess of issues here. Basically, I changed the question. This says cosine and these are sine, and the correct answer choice isn't even here. It would be if I did it that way, but just look at those questions in your notes and your assignment. Make sure you know how to do them. Messed up on this one too, because it says that the radius, well, I changed it, but yours says 5. So basically, if you just ignored the words, you'd be okay. And we're going to find these following values. So my triangle, and we're looking at P. So when I create the triangle, you always go with the x-axis. Make sure you're thinking about those little triangles that we taped in. So yes, the angle that they're actually talking about is this one, but this is my reference angle, and just like everything else, we can use the reference angle. Radius is 13, x value is 5, y value is 12, but we're in the fourth quadrant, so that's a negative 12. I know that sine is y over r, so that's negative 12 over 13. Cosine is 5 over 13. Tangent is y over x, negative 12 over 5. Okay, so here, theta being an angle in standard position whose terminal ray coincides with this line. So, well, it's not going to be beautiful, but. So the line y equals 5x is a positive slope. It's going to look something like that. And so here's what we know. We know that when you have y equals mx, tangent is the slope. It's 5. It's the slope of the terminal ray, and we're supposed to be in quadrant 3. There's the terminal ray. The slope is 5 because that's the slope of the line. I'm going to draw him a triangle with the x-axis, and here's my reference angle. Tangent is y over x, so if this, think about this as 5 over 1, this is 5, this is 1, but since we're in the third quadrant here, this x value is negative, and so the x value is negative, and so is the y value, and then I need r. So I can do Pythagorean theorem, negative 5 squared plus negative 1 squared equals r squared. And so that's 25 plus 1 equals r squared. So that means r is the square root of 26. All right, so when I find the sine, y, which is negative 5, over r, which is the square root of 26, and then that simplifies to negative 5 times the square root of 26 over 26. Cosine, negative 1 over the square root of 26. Rationalize, and I get negative square root of 26 over 26. Okay. Figure at the right shows a circle centered at the origin with angle beta being pi sixths. Find the measure of the angles in standard positions. The other points, okay, so basically these are all my pi sixth angles. So in the second quadrant, it is 5 pi sixths. This would be 7 pi sixths. This one would be 11 pi sixths. That should be old news. Okay, let alpha be an angle in standard position with a terminal ray intersecting a circle centered at the origin at point P. Point P is in quadrant 2. So we're looking at our quadrant 2 angles. Well, this is clearly a quadrant 1 angle. I know this is a quadrant 2 angle. I know this is a quadrant 3 angle. That's a quadrant 4 angle. So same kind of thing, but this time we're in quadrant 4. Well, I know that this is a quadrant 3 angle. This is a quadrant 2 angle. This is a quadrant 4 angle. This is a quadrantal, so it doesn't count at all. All right, so here, now we're in quadrant 3. Okay. Now A, maybe not something that you recognize, so let's just skip it for a second. B, that's pi. Pi is a quadrantal. This is a second quadrant angle, and this is a fourth quadrant angle. So I'm pretty sure my answer is A. But let's talk about how we would know. Now, one thing you can do here, you can reduce this one. But let's say that I gave you like 13 pi over 12. Okay, and then you can't reduce that. You can still think fractionally. This is 0. This would be 12 pi 12ths. This would be 6 pi 12ths. 12 pi 12ths, 18 pi 12ths. So your 15 pi 12ths and even your 13 pi 12ths falls here in the third quadrant. But if this one you can actually reduce, and you can get 5 pi over 4. You divide them both by 3. Okay, so now we're going to sketch some angles. Pi fourths. You want to aim for halfway and show the angle or show the direction of rotation. 2 pi, basically just show your direction there. 7 pi fourths, again we're aiming for halfway. There we go. 2 pi thirds. So 2 pi thirds is about right here. Oops. Well, right there. There's my 2 pi thirds. 3 pi halves. 7 pi sixths. And there are your angles. Okay, so we're just going to evaluate these. I know that sine, and this is in the second quadrant, it's positive, is the square root of 2 over 2. Cosine in the second quadrant is negative, so this would be negative square root of 3 over 2. 3 pi halves, that is a quadrantal, so sine is negative 1. 5 pi fourths, that's in the third quadrant, cosine is negative. Cosine is negative in the second quadrant, so this is negative 1/2. Cosine of pi 6, square root of 3 over 2. 4 pi thirds, that's in the third quadrant, so that's negative, and that would be negative square root of 3 over 2. Pi halves is quadrantal, there cosine is 0. Pi thirds, sine is square root of 3 over 2. 11 pi 6, sine is negative in the fourth quadrant, so that is negative 1/2. Cosine of 0 is 1. Here we're in the third quadrant, so sine is negative, that's a negative 1/2. Sine of pi is 0. 7 pi fourths, cosine is positive in the fourth quadrant, square root of 2 over 2. 5 pi thirds, sine is negative, it's negative square root of 3 over 2. Okay. Here we go. Angle theta in standard position, radius r centered at the origin. Find the coordinates of the point P where the angle, the terminal ray intersect this circle. So remember, we know for a unit circle, it's cosine theta, sine theta, but for any circle, it's r cosine theta, r sine theta. So when I substitute this in, I'm going to get r times the cosine of, no, not r, duh, I know what r is. R is 4, so 4 times the cosine of negative 5 pi sixths and 4 times the sine of negative 5 pi 6. Okay. So that means I'm going to get 4 times. All right, so for a pi 6 angle, cosine is square root of 3 over 2. Got to figure out what quadrant I'm in. Negative 5 pi 6 puts me in the third quadrant. So that means this is going to be multiplied by a negative square root of 3 over 2. And then 4 times, again, I'm in the third quadrant. So sine is also going to be negative, multiplied by a negative 1/2. So that means this gives me, so I'm going up here now, this will give me negative 4 square root of 3 over 2 and negative 4 over 2, which I can reduce those to negative 2 square root of 3, negative 2. All right. Let's look here. The first thing I'm going to do here is sketch in my midline. Okay, then this is asking me for the period. So I can start here and I can end here, which means the period is pi. The frequency is the reciprocal of the period. Midline is an equation of a line, so it is y equals 10. Amplitude is this distance right here, so it is 20. All right, so now we're going to do the same thing, but without a graph. So let's draw ourselves a little picture here. So I have a y value of 15, a y value of 8. No. Y value of 3. X values of 3 and 8. Okay, so when I plot these points, 3, 15 is right here, 8, 3 is right here. Okay. So then I'm looking for the period. Well, this would only be half of a graph, so from here to here is 5, which means the period is 10. Frequency would be 1 over 10. Midline would be halfway right here, so I can do 15 plus 3 divided by 2. That would give me 18 over 2, which is 9. So it's right here, y equals 9. You can double check yourself. 9 is 6 away from 15, 9 is 3 away from 3. I'm sorry, no, it's not. 9 is 6 away from 15, 9 is 6 away from 3. So I'm in the middle there, and that means my amplitude then is 6. Alrighty. Sinusoidal function, let's see, okay, we're doing the same type of thing here, so we're going to make a little graph. I have a y value of negative 1, and I have a y value of 7, and an x value of pi halves, x value of pi. So then I'm going to plot my points. Pi halves is negative 1, pi 7. Okay, so my midline is in here. So, goodness, is in here. So I'm right around here. First thing I can look at here, though, is the period, because this is only half of it, right? And so from pi halves to pi, that's pi halves away. So if I double that, I get pi here, which means my frequency is 1 over pi. Midline, again, halfway. So 7 plus a negative 1 over 2 gives me 6 over 2, and that's 3. Remember, you can always check yourself between these two. This is 4, and this would also be 4. So my midline is at y equals 3, and my amplitude is 4. Right, going through this quickly, but you can always pause and rewind and whatnot. All right, here, first thing I'm going to do before I even read the question is get my midline in there. Maybe it doesn't matter. I guess it really didn't matter here. And so I'm looking at, okay, so I'm going from 0 to pi halves on this first one, right here. So I want to see what behavior best describes f. Okay, so when I'm talking, if f is increasing or decreasing, my y values are getting bigger, so f itself is increasing, so that eliminates these two. Then these two are talking about the rate, so let's make our fun chart so we can get our mind wrapped around the rate. Okay, so we know here the function is concave down and it is increasing, which means my rate is decreasing and positive, but it's decreasing that I'm looking for. My answer is B. Okay, then the next one I'm looking at pi halves to 3 pi halves. Okay, so pi halves to, pi halves to 3 pi halves, this whole part right here. So which of the following best describes the behavior? So we're just talking about f here. This has nothing to do with the rates. So all of the y values are positive. Now 3 pi halves were at 0, but it doesn't include it, so we're fine. So it's positive and they're getting smaller. So it is positive and decreasing. Okay, then the last one, pi to 3 pi halves. That's just this part right here. And here we are talking about the rate of change. So to look at this one, this is concave up and decreasing. So the rate is increasing and negative. So increasing and negative is C. All right. We're going to find the values of A, B, and D here. So again, the first thing I'm going to do is sketch in my midline. Okay? And I'm going to need to find A, B, and D. All right. So here, A is my amplitude, going from 1 to 3, so that is 2. But this has, we are not shifting left and right, correct? And this is supposed to be cosine. My parent function for cosine looks like this. And when I start, since I'm not shifting left or right, I'm starting down here actually, so this has actually been reflected, so this would have to be a -2. Then let me do D, that's the next easiest one. D equals 1. To find B, I'm going to need the period. So if I'm going from here to here, looks like the period is 4 pi. So for B, I'm going to take 2 pi, divide it by 4 pi. That gives me 1/2. All right. And next one, we've got this. I'm going to draw in my midline here. Looks good. Alrighty. So I'm just going to go ahead and find, now this has a shift left and right, but I can go ahead and find A, B, and D before I worry about the shift. So A looks like it is 4. Now it might be a -4, but maybe we can call this amplitude at this point. So we got a 4 going on and we can double check. So since that's the case, I can ignore that one. B we'll get to in a minute. D is at -1. Can't eliminate anything for that. The period goes from 0 to 8. So period is 8, which means I'm going to do 2 pi over 8, which gives me pi/4 for B. And that means I can eliminate this one and this one. But what I'm going to do to make sure that you understand all of these is let's talk about the shifts. Actually, I can do that on the next one, but that just leaves this and I didn't have to look at anything else there. Since there is only one of those, let's go back. I'm going to work it a different way so that I can talk about each shift so that you can make sense of it. So let's just pretend like we haven't marked off anything, okay? Like we can't eliminate anything at this point. Then I'm I want to draw the little parent functions under here. There's a positive sign. There's a positive sign. This is a positive cosine. And then this is a negative sign. Okay? So both of these, neither one of them go anywhere from here. We don't shift left or right. But this one says the amplitude is 3, which it is not. That's why I get to mark that one off. This one says the amplitude is 4. It's positive. All that looks good. But that's where we look for the period and the B value, and that's why we can eliminate that one. When we're shifting this, cosine starts up here. And if I shift to the right 2, if it starts up here, if I shift to the right 2 and I start drawing, then it's going to look like this. But look what happens with this one too. If I start here, that sign, I move to the right 4, and I start drawing, it looks like this. The difference here was these two, and that's why, again, I would need to look at the B. But make sure that you practice and that you've done your assignments with these shifts so that you can read your graphs, because that's something that a lot of people struggled with initially. I think maybe now if you've actually practiced it, you've probably gotten it, but some of y'all ain't practicing. All right. Here I'm going to sketch in my midline. Okay. I can see that my amplitude is 2. Always pay attention to the scale on your graph. Amplitude is 2, so I can eliminate this one and this one. The period, I can start here and end here. Period is 4 pi, so that's my answer. Okay. Population of deer in a wooded area can be modeled by the function d, defined by all this. Based on the model, which of the following is true? Okay, so I'll make myself a little sketch here. And I've got my midline at 5,200. Okay. To find a maximum, I would take 5,200 and add 1,200. So 5,200 plus 1,200. And then for a minimum, I would take 5,200 and subtract 1,200. Right? And so if I'm looking at the maximum number, clearly it's not 5,200. 5,200 minus 1,200, that is 4,000, so I like this. Okay? But then let's also kind of think about what's happening here. If we want to look at what's happening at 0 months, this is my midline. And sign is negative, so my negative sign starts off like this, right? I'd move to the right 2. That's what this means right here. So if I move to the right 2, and I start here, it's going to look like this. I need my period to know where I end. So if I take 2 pi and divide it by pi sixths, that will give me 12. So the period's 12, that puts me at 14. Okay? So that makes this here at halfway between the two, which would be at 8. Between here and here, there are 6 units. Here and here, there are 6 units. So between here and here, which would be -4, that would be 6 units, which means I would have this, like that part right there. So 0 clearly can't be a minimum in there. Could be a maximum, but I can figure out, even from my bad graph, where that maximum is. The maximum is halfway between the two, which would actually be at -1, because my graph is not that accurate. It would be here at -1, not at 0. It's another reason why that's not the right answer. Okay. We've got all this represents consecutive maximum minimum. All right, so let's look at this. I have a y value of 12 and one at 2, and then I have x values of 0 and 2. Plot my points, 0, 12, 2, 2. Not crazy accurate, don't really care. Oh. so then my midline is in here. Not even asking me for the midline, but I need it to figure out what A is. So 12 plus 2 over 2, that's 7. So I'm here at 7. There's 5 units here, 5 units here. A is 5. Then I need the period. Well, this is the part of the graph that I have, and it's only half of it. So this right here is 2. I double that, and the period becomes 4. So then to find B, I do 2 pi divided by 4, which is pi halves. So the answer is B. All right, last one here. I think it's the last one, is it? Oh, no, it's not. So we've got F is at 310. G is at 5.2. J is at 7, -6. So it's much like that first one, but they're just giving you the points so we can do other things with them. 2 and 11, 10. Okay, so those are my coordinates. I want to find the values of A, B, C, and D. Okay, so A, B, C, D. All right, so D, that's my midline. That's the Y value, that is 2. A is also a Y value right here, which also does not happen to be 2, even because if you look at 3 and 5, be careful. You're going from 2 to 10 or -6 to 2. That A is 8. Okay. Then B, I need the period to get B. So if I start here and I end here, the period is an x distance, so 11 minus 3 is 8. So my period is 8, which means I take 2 pi divided by 8 gives me pi fourths. Okay. Then I'm going to find C. Okay, so this is a sine function here. That's important because if I start here, that makes it cosine. So I need this ordered pair, or at the very least, this x value. These x values have a space of 2, 2, from here to here, the x values change by 2, here to here, here to here. That makes this 1, 2 is my ordered pair. So if my sine function, parent function looks like this, but here it's actually starting at 1 right here. Okay, so let's say that's 1. Then that means I had to move to the right 1. When I do that, that would be t minus 1. That's how that works, to move to the right 1. Because this says t plus c, that means c is -1. Or another option is that I started here, which really this is the better place to start because of what is happening, but we could use the minus 9 as well, but we'll use -1. Okay, so then I know it doesn't say to, but I need to be able to write an equation from this. So this would be h of t equals a, which is 8, times the sine of b, which is pi fourths, times t minus 1, because remember I'm moving to the right, and then plus 2. And that's how we put it all together. All right, so this one, it is much like the first one, and most of it's the same. So you don't have to figure out the coordinates again. We've already done that. Okay, so we've got 3 halves. Let me just write in here what we had. 3 halves, 60, 9 fourths, 42, 3, 24, 15 fourths, 42, and 9 halves, 60. Okay. So then let's figure out what else. Let's see, I guess we also figured out that this was 6, 24, and we had also written that this is oops, that this here is is 0.24. Okay, so this says to find the period, frequency, amplitude, and midline. So we kind of found some of that stuff earlier. Let's go ahead, but I didn't call them those things, I don't think. So the period here, the period goes from, so we can say it goes from 3/2 to 9/2, right? So 3/2 to 9/2, I can look at it that way, or 0 to 3, right? I mean, we figured out the period already because it takes 3 seconds to go all the way up and all the way down, so you don't have to make it complicated with this right here. Your period is just 3. Frequency is the reciprocal, it's 1/3. Amplitude is this distance right here. It is a y value, so 60 minus 42, that is 18. And then your midline is an equation of a line, and so that would be y equals 42. Right, so then we're supposed to find 2 intervals for which the graph of h is decreasing and concave up. So this is decreasing and concave up, and this is decreasing and concave up. Right? And so I know that I'm going from my interval, there's x values, 9/4 to 3. Let me scroll so. 9/4 to 3. And then from here to here, I don't have this x value yet, but if this is 9/4 and this is 15/4, that means I added 6/4 to it. So this would be 21/4, 42. So I'm going from 21/4 to 6. All right, then we're supposed to find the values of the constants, A, B, C, and D, which we again sort of already did. So A, we found that, that's 18. B, we haven't found that, but we found the period, so I can do 2 pi divided by the period, so it's 2 pi thirds. C, we'll look at in a minute because I know D is 42 because I'm getting that from my midline. All right, so in order to figure out C, I got to pay attention to what kind of function I have. I have a sine function. I cannot start it here because I can't have the negative stuff. Sine actually, 0 is here, but sine would start here. So that would make, we got to figure out this x value. Well, look, if this is 21/4, 15/4, 9/4, that would make this 3/4, 42. And this is where sine starts, like this. Okay? My parent function for sine looks like this. This one is starting to the right, 3/4. That means I have to shift it to the right. So this would be t minus 3/4 because this says x plus c. So this is going to be a negative 3/4. Then I'm going to write my equation. This is going to be h of t equals 18 times the sine of b, which is 2 pi thirds, times t minus 3/4 plus 42. And that is it. And I did put another option on the key, but just start with the simplest one, because this really has in there what we're looking for. That is it. I would also encourage you, obviously you have to have all of your assignments done. Get your question, make sure all your questions have been answered. Look back over your notes, look over back over the assignments that you've already completed, and be ready for this test.